Okay, here's the preview for the Unit 8 test. We did go over this in class as well. Unit 8 preview over Pythagorean Theorem and special right triangles. Objective 1, Pythagorean Theorem. We have a squared plus b squared equals c squared, and it says find the missing side in the simplest radical form. Make sure you identify your c side. That way you will not miss putting the numbers in the correct spot. C is the hypotenuse. It's always directly across the right angle. So 9 is C. So when I plug it into my formula up here, a squared plus b squared equals c squared, then I will have the numbers in the correct spot. So I have a squared plus 6 squared equals 9 squared, and I know 9 goes here because I've named it C. I'm going to square my numbers. A squared plus 36 equals 81. I need to solve for a squared, so that means I need to move the 36 by subtracting 36 from both sides. I get a squared is equal to 45. And I need to get rid of the square, so I'm going to square root both sides. And a is equal to the square root of 45. Now it says simplest radical form. This was a skill you learned in Algebra 1, and we've used it off and on in geometry. I'm going to take 45, and I'm going to use the ladder method. I'm going to see if I can divide by my smallest prime number, which is 2, which I cannot, so my next prime number is 3. I can divide by 3, I get 15. I can divide by 3 again, I get 5. I can divide by 5, and I get 1. When I get down to 1, that means I'm done. You'll remember the square root of a number is equal to a number to the half power. That means I need 2 numbers to make a whole. So I'm going to circle my 3's. That means my 3 is now a whole number. It gets to come out of the radical. 5 is still a half power, so it stays inside. So a is equal to 3 square root of 5. That is my simplest radical form. Number 2, I want to identify C. C is always across from the right angle, so 12 is C. So I'm going to do q squared plus 10 squared equals 12 squared. Square my numbers. Q squared plus 100 equals 144. I need to solve for q, so I'm going to subtract 100 from both sides. Q squared is equal to 44. I need a single q, so I need to square root both sides. And q is going to equal square root of 44. I am going to need to put it in simplest radical form. So I'm going to divide by 2. 2 is my smallest prime number, and I get 22. I can divide by 2 again. I get 11. My next prime number will be 11. And then there's my 1, and I'm done. So I circle my pairs. I have a pair of 2's. That 2 gets to come out of the radical. 11 does not. So my simplest radical form is q equals 2 square root of 11. Okay, moving on to 3 and 4. Okay, number 3 and 4 says classify the triangle as acute, obtuse, or right using the Pythagorean theorem. Again, we want to identify C. C is always going to be the longest side. So with Pythagorean theorem, I'm going to do 9 squared plus 7 squared, and I want to compare that to 10 squared. I'm going to square my numbers. So 9 squared is 81, 7 squared is 49, and I want to compare that to 10 squared, which is 100. I'm going to add these two together. I get 130, and that compares to being greater than 100. With the legs greater than the hypotenuse, that means it's an acute triangle. An acute triangle. Number 4, I want to identify my C side. That's going to be 20. It's always the longest side. So I'm going to, again, use Pythagorean Theorem. 12 squared plus 16 squared, and I want to compare that to 20 squared. 12 squared is 144, 16 squared is 256, and I want to compare that to 20 squared, which is 400. 144 plus 256 is 400, so that means they are equal to one another, and that makes it a right triangle. This is also a Pythagorean triple. It is a 3, 4, 5 when it's multiplied by 4, which is a right triangle. Okay. Objective 2 is special right triangles. We have a graphic organizer for our special right triangles that is expected to be used. We have a 3x3 grid, and I want to identify the type of triangle. And I'm going to look at my angle measure. So it's a 30-degree angle here, 90-degree angle here, and even though it's not written, I can make it a 60-degree angle based on our triangle sum theorem. So that means I have a 30, 60, 90 triangle. Every single 30, 60, 90 triangle is similar. So the second row is always going to be our side relationships. That is x, x square root of 3, and 2x. Now I'm going to look at my problem. I have ti is equal to 9, so I am going to write that in that spot. And I need to find IR and RT. IR is directly across the 60-degree side, so this is going to represent IR. And I need to find RT, which is directly across the 30-degree side. This is going to be RT. I'm given 9. 9 is directly across the 90-degree side, so 9 is what's going to go in my bottom row. Since I have this row, this column completed, I'm going to make an equation with these two values, the 2x and 9. So here's my equation. 2x is equal to 9. And then I solve for x. So if I divide both sides by 2, x is equal to 9 over 2, or you could have 4.5 as the decimal. Now I just use substitution. I'm going to replace x with the value I solved for. So inside of x, that's going to be the 9 square root, not square root, 9 over 2. And I'm going to replace this x with 9 over square root of 2, and then that's times square root of 3. So RT is 9 over 2, and IR is 9 over 2 times the square root of 3, and we have completed that problem. Going on to number 2, I have a 60-degree angle here. That makes it a 30, 60, 90 triangle. So again, I'm going to make my graphic organizer 3x3, and again it's a 30, 60, 90 triangle. Second row is going to remain the same. The side relationships are x square root of 3, and 2x. They tell me TB is 2, and they want me to find AB and AT. AB is directly across the 60-degree angle, so this is going to represent AB. AT is the hypotenuse. That's going to represent the 90-degree side across from there. And 2 is what's given to me, and that's across the 30-degree angle, so 2 is going to go into my column. That means I'm going to make an equation with these two, and my x is going to equal 2. I don't have to solve for anything because x is equal to 2. Now I'm just going to substitute in. In goes 2 for x times the square root of 3. And I'm going to have 2 times 2, which is going to be 4. And AB equals 2 square root of 3, and AT equals 4. Okay, continuing on with special right triangles. Okay, number 3. I have markings here and here that indicates that it's congruent. I have a 45-degree angle, which makes this angle 45 degrees as well. I have a 90-degree angle, so that makes this one 45 and this one 45. That means I have a 45, 45, 90 triangle, which is different from the 30, 60, 90. I still have a graphic organizer to use, except this time on the front row I have 45, 45, 90. And the relationship between the sides are x, x square root of 2. Yes, the 45s are the same because it is an isosceles triangle. I'm given TO is equal to 6. That is across from my 90-degree angle, so 6 is going to be filled in under the 90-degree column. And that means I have my equation, x square root of 2 is equal to 6. So to solve for x, I need to divide by square root of 2. And that'll eliminate, and I get x is equal to 6 square root of 2. Unfortunately, I can't leave the square root of 2 in the denominator, so we have what's called rationalizing the denominator. I'm going to multiply the numerator and the denominator by the square root of 2 since it's the same as this one. What that allows me to do is it allows me to get rid of the square root of 2 in the bottom. I multiply straight across. 6 times square root of 2 is 6 square root of 2. Square root of 2 times square root of 2, that cancels out the square root and leaves me with the regular number 2. And then I can simplify 6 divided by 2. So my x is equal to 3 square root of 2. That's what's going to go into my x, 3 square root of 2. And the other x is exactly the same, 3 square root of 2. Okay, number 4, they tell me SQRE is a square. That means I have 4 congruent sides, and I have 4 right angles. That's enough information to tell me that I have a 45, 45, 90 degree triangle. And again, I'm going to draw my graphic organizer. I have a 45, 45, 90. They are all similar to each other. And my side length relationships are x, x, x square root of 2. This time they tell me ES is 3, so ES is 3, and they want me to find QS. QS is the other 45. I'm going to write QS here, and then EQ is across from the 90. So the 3 is across from 45. That means 3 goes here underneath the 45, and my equation is x is equal to 3. And that means I'm going to fill in QS with 3 because it's also x. And then I'm going to substitute in 3 here. My EQ is 3 square root of 2, not 3. 3 square root of 2. Okay? Next, we have the similarity problems. Okay, similarity triangle theorems. We had 3 theorems. We had side, 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 angle, and angle, angle. We have to show proportionality, that they are the same ratio on these two, that they have to have the same ratio. So on problem number 1, we have 6, which is EN, 4, which is ME, 108, which is ET, and 76, which is RE. And then I have the angle MEN is congruent to angle RET. To prove these are congruent, I need to show that the sides are proportional. So 108 corresponds to 6, 76 corresponds to 4. and I'm going to take a brief break.